Okay, part 1. Determine if each of the following relations is a function. So, what you want to do is look at the x. There's no x that repeats. So every one of these airplanes is going to a different airport. So this one's yes. It's a function. This one is, 4 can't go with 2 and 4 can't go with -2. So it's no. This one is no. This one is yes. It passes the vertical line test. This one is no. It doesn't pass the vertical line test. And this one is no. It doesn't pass the vertical line test. Down here it reads, find the solution for the given equation and the x value. Write your answer as a coordinate pair. So coordinate pair is the same thing as ordered pair. So what you're going to do is you're going to plug -2 in for x. So it's y equals -2 plus 5. That equals 3. So your coordinate is going to be -2, 3. And then letter number 8, you're going to plug in 5. So y equals -4 times 5. So y equals -20. So your ordered pair is x is 5, y is -20. Number 9, you plug in -6. So it's 1/2 times -6 plus 3. -6 divided by 2 is -3 plus 3 is 0. So your ordered pair is -6, 0. And then 10, find the slope between the given points. So the slope, you use a formula y2 minus y1 over x2 minus x1. So this is x1, y1, x2, y2. So 1 minus a -1 over 4 minus 3. So this is 2 over 1. You want to reduce it to 2. -7 minus 5 over 10 minus 8 is -12 over 2. And you want to reduce that to -6. And then next part, identify the slope and the y-intercept in each equation. So the slope is the number that's in front of x, so it's -2/5, and the y-intercept is 3. This one, the slope is -1, and the y-intercept is 0. Graph the following lines. So when you do this, you start at -2, make a dot, and the slope is 1/3. So you go up 1, right 3, make another dot. Or down 1, left 3, make a dot. In this equation, you start at 1, and you go down 2, right 1, down 2, right 1, or up 2, left 1, up 2, left 1. Connect the lines, put arrows at the end. Number 16, write an equation. Tickets to the play cost $10 plus a $4 processing fee for each order. Write a linear model to represent the total cost, C, of T tickets. So here are two variables, C and T. The cost is the total. So the cost to go to the play is $10 a ticket. So it's going to be $10 a ticket plus $4 no matter what. If you order 5 tickets, so let T equal 5, what is the cost? So it's going to be cost equals 10 times 5 plus 4. Cost equals 50 plus 4, which is $54. And then the next one, a snow shoveling business charges $50 per hour plus a $10 one-time fee. So $50 per hour. Write a linear model to represent the total cost C after H hours. So we need to have two variables. Cost equals $50 an hour plus $10 for a fee. If you spent $210, so if your cost was $210, how many hours, so solve for h, did it take? So I'm going to write 210 equals 50h plus 10. Subtract 10. 200 equals 50h. H equals 4 hours. Okay, this one we skip because the scatter plot didn't show up. Okay, next one. Use the data in the table to make a scatter plot. So if I plot 10 to 40, I go right 10 and I go up to 240, which is just short of 250. So this is my first dot. 20 to 15, go over to 20 and go up to 215. 30, 195 is almost 200. 40, 165. 50, 150. And 60, 125. So we did that. Use a straight edge to draw a straight line, a trend line. So your trend line doesn't have to go through any dots. Oops. Okay. So if you were to read this trend line, you could go to 35 degrees. You would expect to sell about 185 cups of cocoa. That's how you would read it. Or if the temperature was 15 degrees, this looks like 235. That's how you read it. You read your line. You don't read the dots. You read the line. It's positive, negative, or no correlation. This is negative because it goes down from left to right. Solve each system by graphing. So what you want to do is you want to graph each line. So the first line I'm going to graph in blue. So I start at -3, and I can either go up 1, right 2, up 1, right 2, or down 1, left 2. And I connect my dots. Then I'm going to draw the red line. I start at -1. I go down 1, right 2, down 1, right 2, up 1, left 2. So my solution is where they cross. So right here, I have to write this as an ordered pair. So the x is 2 and the y is -2. Second one, I'm going to graph my first line. So I start at -1 and I go up 1, right 1, up 1, right 1, up 1, right 1. Like that. Solid line. Oops, it's not a less than or a greater than. Then I graph my second line. Start at 0 because there's not a 0. Up 1, right 2, up 1, right 2. So I know my line is horrible, but where these two cross are these two dots right here. So this x is 2 and the y is 1. Now down here, inequalities are when you have to shade or have a dashed line. So remember, if it's greater than or less than, it's going to be a dashed line. If it's greater than or greater than equal to, you're going to shade above the line. If it's less than or equal to, you shade underneath the line or the ladder. So first off, you graph like you normally do. Start at 5, go down to right 1, down to right 1, down to right 1. Then, because it's greater than, it's going to be a dashed line. And this is a greater than symbol, so think about a person being on the ladder. You shade above the ladder. This would be below the ladder. We shade above it. And then number 29, you start at 0, up 3, right 4, down 3, left 4. Make a solid line because it's less than or equal to. And then I'm going to shade less than. So if you have a person on the ladder, you're going to shade underneath that person on the ladder. And then the last part lists a domain. So domain's all the x values. The range is all the y values. And is it a function? So look at your x's, -2, 2, 3, -2. Because -2 repeats, it's not a function. And the domain is you put in brackets all of the x values from least to greatest. So I have -2, comma, I already did that, 2 and 3. Those are all my x's. Now the range is all the y values. So I do a bracket. This is called a bracket. Then I write them from least to greatest. So a 0, a 4, 11, and a 12. So domain, x's, range, y's.